Alright, so last chapter we dealt with negative exponents. What did a negative exponent do? Like, makes it go to the bottom, right? Like x to the negative 2 is the same as 1 over x to the 2, right? So negative makes it go to the bottom. We know normal exponents. We know negative exponents. The only other thing is fractional exponents. Isn't that exciting? So x to the 1/2 is the same thing as the square root of x. When you make a base to a power, and that power is fractional, the top number is the power just like normal, but the bottom number is the root. The bottom number is the root. Bottom number is the root. Alright? So if you have x to the 1/3, that's the same as the third root, or the cube root of x. X to the 1/4 would be the fourth root of x. Does this make sense? If there's a bottom number, you just put that number here in the root sign. But then what happens, it gets a little crazy, is when we mix that up when you have a numerator and a denominator. So 4 to the 3/2 is the same as 4. Where does the 3 go? Does it go here, or does it go with the 4? It goes with the 4. And then the 2 goes where? Right here. And the 2 is the only one you don't have to write there, but if you want to write it to help you remember, more power to you. Okay. This one gets a little tricky, because that's the square root of 4 is the same as 2 times 2. Right? With me so far? So this is the same as the square root of 2 times 2, 2 times 2, 2 times 2. Does everybody get that step I just did? 4 is 2 times 2. So I did 2 times 2, 1, 2, 3 times. Right? Almost there. We remember this is like a gatekeeper. That means everybody can come out as long as they come out in pairs, right? So I have 1 2 that gets to come out. I have a second 2 that gets to come out. I have a third 2 that gets to come out. 2 times 2 times 2. Is there anything left on the inside? No? So my answer is 8. Now this is the way that's always going to get you to a right answer. Sometimes it just works out nicely. If you look, if we just did it one step at a time, what is 4 times 4? 16 times 4, so that's 4 to the 3rd power. 64, what's the square root of 64? 8. So if it works out nicely, a lot of times you can just kind of do it in your head. Yeah?
Wait, so can we do it that way if we want?
Sure, but it's not always going to work out.
So then can't we just like branch out?
Mm-hmm.
What will it not work out? What depends on that?
I'll show you. We'll get to one where it's not so pretty. Real soon. I promise. Alright, let's try this next one. 27 to the 3/4. That means, and I encourage you to do this next step. If this is a number that breaks down, you can go ahead and break it down right away. 27 is what times what times what? 3 times 3 times 3. That's the 27. Where does the 3 go? Inside or outside? This 3. That one goes inside. The 4 goes outside. Alright, so that's the same as the 4th root of 3 times 3 times 3. 3 times 3 times 3. 3 times 3 times 3. Right? Because I have to have 3 times 3 times 3 3 times. In other words, 9 3's in there. If I have 9 3's in there and the gatekeeper says 4, they come out in groups of 4. That means this is 1 3 that gets to come out. This is 1 3 that gets to come out. And who's left inside? One lonely little 3. So 3 came out, a second 3 came out, 1 3 had to stay in. Anything outside you got to recombine. What's 3 times 3? So the answer to this would be 9 times the 4th root of 3. That's an example of where it's a little less pretty if you try to just go 27 to the third power. And on top of that, Alani, like, what's 27 times 27 times 27? A really big number you don't want to deal with, right? So if you break it all down first, you don't have to do as much big math. Andres, you have a question?
Yeah, I was just going to ask, you never have to mess with the radical that's, I mean, with the exponent that's the top of the
No, that's just once you put it there, it's always going to be there. Yeah.
But you don't want to do it because it's just going to remember. But like, what if you have a calculator? Is it still work?
Yeah, if you can figure out how to use your calculator, more power to you. The problem is we're going to get to points where it's not always a number here. Sometimes it's variables there. And so you still have to understand how it moves around. Okay, why don't you guys try this last one? And then we'll do it together. But try it, 81 to the 3/2.